Alright, and welcome back, grade 12s. Today we're going to look at section 5.1, graphing the sine and cosine functions. What we're going to do to start with is I'd like you to make this table in your notes, a table that uses the special angles that we've learned so far this semester, especially in the last trig unit. So starting with angle, let's go angle 0 radians, and then pi over 6, and pi over 4, pi over 3, and pi over 2. And I'd like you to use your knowledge of the special triangles to calculate the sine of each of those angles and the cosine of each of those angles. Okay, so pause the video, use your triangles, fill in the missing numbers, use your triangles to calculate sine and cosine, pause the video, write those numbers in, and then come back. Now if you did this correctly and you plugged in the proper numbers for the sides of the special triangles, then you should have each of the following values for sine and each of these values for cosine. Now what I want you to do is I want you to extend that table so that you continue. So we have pi over 6, pi over 4. Remember, this is like in the circle. We've done this angle, pi over 6, pi over 4, pi over 3, pi over 2. So now I want 2 pi over 3, 3 pi over 4, 5 pi over 6, all the way to pi, and then continue with those 3 and 3 pi over 2, and these 3 and 2 pi. So I want you to continue these angles all the way down to 2 pi. Pause the video, check them out. Remember what you know about positive and negative sine, cosine, etc. in quadrant 1 and 2 and 3 and 4. Okay, so pause the video, fill in the table, and then come on back. So you probably started by trying to figure out what all the angles were, and I hope you're in agreement with what you see here on the screen on the left. So remember that these values are going to have, so 2 pi over 3, 3 pi over 4, 5 pi over 6, and this is really important here, they're going to have the same values for sine, cosine, or sine as their reference angles do. So 2 pi over 3 is going to be root 3 over 2. And because it's in quadrant 2, sine is positive. 3 pi over 4 will have the same sine value as pi over 4 does. So 1 over root 2. And 5 pi over 6 is going to match up with pi over 6. So 1 over 2. So we came from 0, built up towards 1, and then came back down towards 0. Now, in quadrant 1, all of these were positive. In quadrant 2, all of sine is positive. But in quadrant 3, the sine of these angles is going to be negative. And that kind of makes sense because my sine value is growing from 0 towards 1, sort of maxes out at 1, comes back towards 0, and keeps on going into the negative realm. 7 pi over 6, same sine value as pi over 6, so 1 over 2, sorry, let me erase that. 1 over 2, but it's negative. Look at the pattern here. 5 pi over 4, related to pi over 4, so 1 over root 2, but it's negative. And again, look at the pattern there. So I hope you can see that the next one must be root 3 over 2. So we've been going down from 0, and at 3 pi over 2, we should get to negative 1. This was negative, by the way. And then we're going to start building back up towards 0 again. Sine of 5 pi over 3 will be negative root 3 over 2. Look at the pattern. 7 pi over 4 will be negative 1 over root 2. And 11 pi over 6 will be negative 1 over 2. And finally, 2 pi is going to bring us back up to 0. So use that idea, use the patterns, and fill in the cosine values. Pause the video. Pause the video, do it yourself, and then check. Okay, well I hope you did those on your own. Now when we look at the values, we can see that for cosine we actually started at 1 and worked down towards root 3 over 2, 1 over root 2, 1 over 2, and then down to 0. And then like we did with sine, from 0 down into the negatives, because cosine is negative in the second quadrant. In the third quadrant, cosine is still negative. And then in the fourth quadrant, it turns out that cosine is positive. So this is actually quite neat because there's a periodicity here. Things are repeating. We can see a pattern. And this graph, if we graph the sine function or the cosine function, it's periodic. It repeats itself. You may have heard this word before. It's sinusoidal. Exciting word. So the next thing I want you to do, what we're going to do is we're going to graph these functions. We're going to graph the sine theta, y equals sine theta, and we're going to graph y equals cosine theta. So our x-axis, what we typically think of our x-axis is going to be theta. And make it nice and long. Make it about the width of your page. And make your y-axis about 8 lines tall. So this is going to be y. And let's make let's make 3 lines here. We'll make that 1 and negative 1 over here at 3 lines down. Now once you've drawn that axis, I'd like you to split the length of it into 3 equal parts. If you're on graph paper, if you could go across 18 lines, that'd be swell. Okay? So our first tick mark will be pi, second tick mark will be 2 pi, and then let's go even a little further to 3 pi. We're going to get to a maximum of 1 and a minimum of negative 1. Now if you go back to the table, you'll recall that y equals sine x. When theta was 0, let me change colors here. When theta was 0, sine was 0. When theta was, where was it here? When theta was pi over 6, sine was 1/2, then 1 over root 2, then root 3 over 2, and then 1. So 1/2, that's about here. I'm just going to put a dotted line here at 1/2, just so I can see where that is on my graph. And negative 1/2. Those are convenient points. I'm also going to have a maximum here at 1 because we saw that our sine value went to 1 and then it came down to negative 1. It's just to help me graph a little bit. These dotted lines are not part of my graph. This dot is though. And at pi over 6, so if this is pi, 1/6 of pi is here. Right? 1, 2, 3, 4, 5, 6 of them. So this is pi over 6. And that's equal to 1/2. At pi over 4, which is, let's see, if this is halfway, this is pi over 2. And this is half of that. So this is going to be pi over 4 here. Things were equal to 1 over root 2. And if you plug that into your calculator, you'll get 1 divided by the square root of 2 is about 0.7. So this is about 0.66. This is about 3. 0.7 is about here. And then root 3 over 2, 3 divided by 2, comes in at 0.866. So here's about 0.75, 0.866, somewhere in here, and that's at pi over 3, right? 1/3 of pi, 0.866, that's up high here. And then at pi over 2, y was equal to 1. So if you sketch this out, that's like this curve that comes up towards pi. It's actually a little higher here. There we go. And then you'll recall it comes back down again at 2 pi over 3, at 3 pi over 4, And at 5 pi over 6, we have these points repeating themselves. And then it comes back down. At 3 pi over 2, it was equal to -1. And at 2 pi is equal to 0 again. So that's the graph of y equals sine theta for different values of theta from 0 to 2 pi. You can do the same thing for cosine. Cosine starts when theta is 0, cosine starts at 1. At pi over 2, it's 0. At pi, it's -1. At 3 pi over 2, it's 0. And at 2 pi, it's 1 again. Now, it's not a V, but it curls down like so, and like so. And these graphs continue. If I continue with the blue one, same pattern. At pi over 2, which is here, it was up, and at 3 pi it'll come down. And for the red graph, it's going to cross at 0 and be at -1 at 3 pi. And it goes on forever. Okay, it keeps on, and back here as well, it goes on forever. Now, if you want to copy these down, pause the video because I'm going to erase one of the lines, and then I'm going to talk about some language around these graphs. Alright, so I wonder if you can tell me which graph we've got here. Is it y equals sine x or y equals cosine x? And I hope you can tell that this is y equals cosine x. And if you didn't know right off the bat, don't worry about it. We're going to do a lot of these and you're going to learn it fairly quickly. You'll learn to recognize these and you'll learn to do all sorts of different things with them. Now, there's some language that we need to know. The length of time, or the length, the horizontal distance between one point, like this one, let me highlight that in yellow here, between this one and an identical point like this one over here at 2 pi, that's called the period. So if I go from here all the way through to another point in the same at the same height, that's called a period. Okay, so this would also be a period. The distance between those 2 points is the length of that period, so that's called 2 pi. I should change that language here. What I mean to say is the distance between two identical points is the period, and that distance in this case is 2 pi. What I've got here, as I follow this whole thing, this is one cycle. That cycle has a period of 2 pi. So let me erase this point up here and say that this is a cycle. This is one cycle. Okay, the graph starts here, comes down, goes back up. Okay, it has a period of 2 pi. This is a sinusoidal curve. There's some other language I think we talk about. Yes, we do. We talk about the amplitude of the graph. So the amplitude is the difference between the maximum height and the minimum height divided by 2. So from 1 to -1 is a height of 2, a total height of 2. The amplitude is from the middle all the way up. So this is our amplitude, and it's equal to 1. Half of the distance between the top and the bottom amplitude. We've talked about the period. We've talked about the length of one cycle. So that should be good for now.